Today, let's talk about derivatives. The first is historical background. Derivative is a core concept of calculus. It was first proposed by the French mathematician Fermat in 1629 in the study of tangents and extrema values of the problem. He was doing tangents, constructed the difference fa plus e minus fa. Find the factor e is what we now call the derivative. And the next is definition. Let f be a function. First, suppose that f is differentiable at every point belonging to an open interval a to b. Then we say that f is differentiable on a to b. Second, suppose that f is differentiable at every point belonging to its domain. Then we say that f is a differentiable function. And let f be a function that is differentiable at some point belonging in its domain. Then the derivative of f, denoted by f, is a function from a subset of dom f into R given by f dash, where the domain of f dash is x belong to dom f. And here are some common derivatives. And the next is rules of derivation. Constant multiple rule for differentiation. And second is sum rule for differentiation. And the third is derivative of polynomial. And the fourth is product rule. And the last one is quotient rule. And here's the example. Let fx equals 6 times x to the power of 8 plus 7 times x to the power of f minus 2 times e to the power of x. Find the derivative of fx. And the solution is the derivative of fx equals d 6 times x to the power of 8 plus 7 times x to the power of f minus 2 times e to the power of x by dx, and equals d 6 times x to the power of 8 plus 7 times x to the power of 5 minus d 2 times e to the power of x by dx, and equals 48 times x to the power of 7 plus 7 times dx to the power of 5 by dx minus 2 times d e to the power of x by dx, and equals 48 x to the power of 7 plus 35 times x to the power of 4 minus 2 times e to the power of x. And the last is about its applications. In neural networks, the derivative or gradient is a very important concept that plays a key role in training and optimizing neural networks models. And the first is gradient descent optimization algorithm. Gradient descent is a method of updating model parameters by following the gradient of the loss function in the opposite direction. By taking its derivatives, it is possible to see how the loss function will change if it is decreased or increased as the current parameters values. Iterating in this way repeatedly, the parameters are adjusted in the direction that minimizes the loss function, thus minimizing the loss. And the second is backpropagation. Backpropagation is a common method used to train neural networks by calculating the partial derivatives of the loss with respect to the parameters, the gradients, through the chain rule, as a way of updating the network with parameters so that the model adjusts the parameters in the direction of decreasing loss.